Welcome to the summer 2021 edition of Open Source Research Experience. A quick introduction. I'm Carlos Malzahn, adjunct professor at UC Santa Cruz, the Computer Science and Engineering department, and also the founder and director of the Center for Research in Open Source Software, about which we will talk a little bit today as well. I'm also the co-founder and director of the UCSC Systems Research Lab. Before I joined UC Santa Cruz, I was a performance engineer at NetApp. I'm currently advising 6 PhD students, and I graduated 9 PhD students and 10 master's students. So if you want to know more information about my current research and past research, go to my website at people.ucsc.edu/carlosm.
Great. And then I'm Stephanie Ligi. I'm the Associate Director of Cross, and I've been here since 2016. One of my main focuses here at Cross is supporting open source communities, enabling them to kind of create sustainable contributor bases, and also promoting the use of and development of open source in the academic setting. I also am very strongly committed to increasing the diversity and inclusion within the open source communities, and hope that in some ways the OSRE and other projects we work on will help us in that way. My previous background is completely different. I actually came to Cross after having spent 15 years as a researcher in the non-proliferation field. But in that field, actually is where I came to understand the importance of open source and open source technologies, both for academics as well as for the research community as a whole. So that's one of the reasons that I was happy to move over to UCSC and start working with Carlos at Cross. Well, what we're going to talk to you today about, and hopefully answer any questions you might have about, and hopefully you will all find very interesting, is our open source research experience. This is a summer program that includes students, mentors, who a number of them are here today, and sponsors, which hopefully also a number of them are here today. The OSRE, as we call it, is focused on bringing more students into open source and a more diverse group of students as well. Students work with our top researchers on a summer project. It is similarly structured to the Google Summer of Code, which is how we were inspired by it. And it fits really well in Cross's mandate and our goals of increasing education in open source strategies, particularly in the undergraduate level. And we do this with this program really by enabling very hands-on, impactful experience for students over the summer. Last year, we were lucky to have 11 students working with us, a good number from UCSC, but also a number of students from outside of UCSC, including 4 students from, 4 students from other countries, including 2 from Mexico, 1 from India, and 1 from Nigeria. And our student feedback was great last year, where we had a lot of significant interaction with their mentors, which really they felt was a huge help and a huge boost to their professional and technical development. So I thought that was really showed a definite plus and success for our program last year. Just to get started on what the structure is for OSRE, is that we basically have 3 main stakeholders, and we'll go into these in detail as we proceed. The first is the sponsor, and those are organizations outside of UCSC, be it industry or other types of organizations that engage with our researchers and the students that our research have chosen on these exciting new open source projects and innovations that are coming out of Cross projects. We also have our researchers, and Carlos will talk about them a bit in more detail, but typically they are researchers from our Cross projects. They're faculty or senior graduate students from UCSC. And then we have our students, kind of the backbone and kind of the main focus of this project or this program. And they spend their summers writing code and contributing really good work to the main open source projects that are funded by CROSS. You have some application deadlines on this slide, and we'll go into all that in more detail on a couple other slides. This is the timeline that we have at this point. You'll see that we've already gotten going. February is when our mentors, or also the researchers that I was just talking about, uploaded a bunch of ideas to the ideas page. And so we'll talk about those a little bit more in detail in a couple of slides, and also a number of our mentors will go into detail about some specific work that they're thinking about for the summer a little bit later. Those ideas are already up there. They've been up there since February, and so you can take a look at them. And the next kind of big date would be April 9th, when we would want to have pledges from sponsoring organizations to be kind of in, and we'll tell you the process of how to do that in a bit. We also have, when our funding's due is in May, and then basically this, the whole timeline kind of lays out until October. And we're going to go through step by step on this in some later slides. So with that, I'll turn it over to back over to Carlos and let him talk a little bit more about our researchers.
Thank you, Stephanie. So this is an exciting program, and we wanted to talk a little bit more about, who's organizing this and where these researchers come from mostly, right? As Stephanie already mentioned. Next slide. So the Center for Research in Open Source Software was founded in 2015. And its mission is to bridge the gap between student research projects and open source projects. And it's been inspired by one of our former students, Sage Weil, who created the Ceph storage system, which is today a very popular and widely used distributed storage system, open source storage system. And we found that this path of moving open source projects or moving research projects out into the industry or into the world as open source projects is really a way to amplify the research and the impact of university research. CROSS is sustained by an annual membership and $2 million Sage Weil gift. The three components of CROSS is education, research, and incubator. We teach students to productively engage in open source software projects. We fund high impact research that have a potential path to an open source software project. And we, most importantly, incubate developer communities around research prototypes. Next slide. So I'm going to go through in the next slides, I'm going to go through these three components of all the components of CROSS. There are 5 components: education, research, incubator, and then the UC Santa Cruz faculty, and then the members of industry, right? And you see on the upper right corner sort of a map of where we are right now. So the education component, open source research experience, which is the topic of today's talk, is situated as part of the CROSS education program. Then we have some other very interesting parts, like for instance, a commercial open source workshop series that we have created in partnership with Professor Dirk Riele from the University in Erlangen-Nuremberg. And he's going to actually give that workshop series. He gave it last year, but we'll give it again later this year. And it's been very successful. We also have created a new class, a new course. It's an undergraduate course that has been very popular. It's called Open Source Programming. It's very hands-on. It teaches students the tools, and it basically students learn how to get involved in the Linux kernel community. And finally, we have a speaker series that give talks on open source technologies, practices, entrepreneurship, community management, and also legal aspects of open source software and open source in general. Next slide. So most of the innovation in CROSS comes from our research program. We have currently 6 research projects that span storage systems, databases, open source hardware, like the autonomous vehicle controller by Aaron Hunter, as well as hardware development, the hardware development toolchain that is led by Shenghong Wang. So an interesting variety of open source projects. We also graduated successfully 4 research fellows that now work in industry. And one of them, actually, Ivo Jimenez, has become an incubator fellow. We measure these research projects by their publications and the awards. Very traditional. It's actually not the production of software that's the focus of these projects, but actually real research innovation. Next slide. In the incubator, in the CROSS incubator, we have 3 projects, of which one recently graduated, Kate Compton. She is engaged in teaching people how to program, people who don't see themselves as programmers, so poets and artists, and has been very successful with that. Ivo Jimenez, as I've already mentioned, he has been building a reproducibility platform and also founded practical reproducibility workshops that are well attended, and now I think in its 4th year. And Jeff LeFevre, who you will hear later today as well about Skyhook, which is an Arrow native storage built on top of Ceph and also Arrow, Apache Arrow projects. So the evaluation of these projects is really the number of contributors they have in their project, how it's growing, and the number of organizations involved in these projects, right? So the idea is to create really open source software projects that are robust, that have a large community buy-in, and it's also fit well into existing ecosystems. So both the CROSS research fellows and the CROSS incubator fellows are the people who are part of the mentorship for the open source research experience. So you can see that these are very highly qualified people. They're already well regarded in their communities. There are experts in their domain, and they work on very exciting projects. Next slide. At the faculty side, we're particularly proud of our advisory committee. Doug Cutting is well known for his role in literally creating the toolchain, at least the early toolchain of big data with Lucene, Notch, Avro, and Hadoop. Karen Sandler, who is the executive director of the Software Freedom Conservancy, has a long experience with open source software, community practices, and legal aspects. She's also very engaged in enforcement of GPL, for instance, and we're really glad to, she's very interested in actually fostering open source software practices and strategies in universities. And Nisa Strutman, her background is industry. She has, many years of experience in the legal landscape of open source in industry and corporations. Sage Weil, who's who sparked this whole idea of CROSS. He is from a student of UC Santa Cruz and created Ceph and and is is very much engaged in the center, and we love his advice. And James Davis, one of UC Santa Cruz faculty at School of Engineering, at the Computer Science and Engineering department. He is very interested in entrepreneurship within the university context. And so all in all, we're super proud of our advisory committee members, and their advice has been critical for the success of CROSS. Next slide. Lastly, but not least, we'd like to thank Sage Weil and our sponsors for sustaining CROSS. Sage Weil, as I mentioned, kicked off the founding of CROSS with a $2 million gift. And we have now outraised him with industry sponsor membership fees of 2.3 million so far. We are now 5.5 years into this. Our current sponsors, Kyoshia, Seagate, and Fujitsu, thank you so much for your continued support. And our past sponsors, SK Hynix, Micron, Western Digital, Huawei, and Samsung for the past support, and we hope that we are will get them into CROSS again. Next slide. So there are two ways to engage in open source software in the School of Engineering. So one is the open source research experience that we're going to talk in more detail in the following slides. The other one is to become a CROSS member. When you are a CROSS member, you can actually influence the topics that we're working on. And we have a semi-annual call for proposals that calls for project and research projects and incubator proposals. These projects are often blueprints for standardization efforts. And you get to, as a CROSS member, you get to recommend selection and renewal of projects. We have an industry advisory board meeting twice a year, but you can also participate on a weekly basis on our research and incubator project meetings. And by doing this, by supporting us this way, you encourage open source software research prototyping. This has really changed a lot of research agendas of the faculty at UC Santa Cruz, and to think about how they can leverage open source approaches for their research. And this is a really good news, I think, for everyone, especially for the industry working with us. You know, if you're interested to become a member, and that might be after you've been working with us as part of the open source research experience, please contact us, right? You can contact Stephanie or me, or just send an email to crossinfo@ucsc.edu.
Right. So just to kind of look at the mechanics of the program, first off, just to highlight again what the purpose of the program is, to really jumpstart these developer communities in a number of open source projects, particularly the ones that are funded by CROSS, and give a lot of really important, relevant open source experience to a good number of undergraduates. And again, these are very hands-on, relevant tool building type projects that they get to work on. They get mentored by people who are leaders in their domain. They're experts in their field. And that's definitely been something we've seen hearing back from our students from last year, and also students who have been in similar projects or programs working with us, that working with these experts has been hugely important to them and their professional development. And then also there's a great opportunity for sponsors to engage in CROSS activities, across the innovations that are happening in CROSS projects. Again, so here is, and that's before maybe giving an idea of, before you become possibly be members, that this would be a great opportunity to kind of get to know CROSS and some of the great work that we're doing. So you see this, well, I'll go into each detail about the timeline and the mechanics with regards to becoming a sponsor. So as I said before, we already have project ideas up. Anyone can take a look at them. This is the website for them. That site is also, there's a link for that website on the main OSRE page on the cross website. You should be able to get a link from the invitation that you received as well. So you should be able to view these. They're updated, and they have. I think we just added some new projects just the last couple days, and this has actually been up, like I said, since February, and part, because we wanted to get a good idea of the type of projects and the mentors, for both for sponsors and for others who might be interested in this program. So step one, if you are interested in becoming a sponsor, is really to kind of take a look at these project ideas and for the overarching cross projects that are connected to it that the mentors are working on. Now, just note the project ideas are kind of the basis, just to kind of give an idea of the background of how these project ideas work. They are kind of the basis of the student proposals, and the students will work. So the ideas are come up from the mentors, and then the students see those ideas, and then they work closely with the mentors they're interested in working with prior to the proposal deadline. So the mentors are very integrated into helping the students writing the proposals. They don't write it themselves, but they give a lot of feedback. Again, this is very similar to the GSOC model. If for any of you who've experienced that. What's great about this, and why I think it creates definite successes, and we've seen it, and why we've seen so many success stories with regards to the projects we've run this way, is that the mentors really get to know the students way before they have to really start working with them in coding. And it's great that generally it means that our mentors are really able to know ahead of time who's going to be the best match and who's going to have a successful project. And really I have to say, over the last year's projects, which are, like I said, 11 of them, and then our experience previously with GSOC, we've had 100% success with all of our projects meeting the goals and their milestones. So it's been great. It's been really, really rewarding, both for us and for the students, I believe. But back to what sponsors were doing at this point. The first step one for the sponsors is that you look at the project on the ideas page, and you kind of and you listen to the mentors also that are going to talk today, and you kind of figure out which projects you find to be most interesting or you see as most relevant to you. Now, step two is the actual pledge, and this is something that we're asking sponsors to make by April 9th. There is a form, simple Google form, set up. Again, this link is on the main Cross website and the main OSRE webpage within our website. And for anyone who actually registered, whose emails I have, I will be sending out this information to everyone directly by email as well. And on the OSRE page, you're basically, the pledge page, whoever sponsors will be asked to just give their basic contact information for their organization, who the contact is within the organization, the pledge level, which I'll talk about in a second, and then which projects they're most interested in. And you'll see that there's a drop kind of, this little Dropbox area, selection area with each main cross project listed. So you can select one of those. And as well, if you have very specific, like a sub-project or one of the ideas that you were interested in, there are areas below to enter in that information as well. If you say, I see one from LiveHD that I'm particularly interested in, you can list that to let the mentor know which ones you're specifically interested in. You can also add other information or other thoughts about projects you think would be useful to have up there as well. The sponsors have the input from sponsors is very, very important to us. These are the sponsorship levels. We were also going to add, we're going to also, if there are people who are maybe not able to pledge or not able to be sponsors this year, but do want to put some input into projects they're interested in, we're more than happy if you want to use this page also to just give us some input. That's great too. But for those who are interested in sponsorships, this is the rates. The funding goes specifically, almost the vast majority of that funding is going specifically to cover the costs of a student working 40 hours a week for about 12 weeks. And at a rate that would be considered a rate that could help at least living in Santa Cruz or wherever they're living as a living wage. So it's a paid internship. And again, but if there's, we think most organizations would probably be interested in sponsoring one student, but there are definitely organizations that might be interested in sponsoring multiple students. And if you're an organization that is interested in doing that, we're definitely giving some level of discount for multiple students, as you can see from the costs here. Again, this goes, all of the funding, the vast majority of the funding really goes straight to the students and supporting the mentors, and just a little bit on overhead for UCSC. The pledge page is filled out, we will contact you with an invoice, and then the sponsorships will be paid as gifts to Cross, and those will be expected to come in by May 13th. And the reason we picked a slightly early date was just because we really wanted to make sure that the funding was assured prior to making a formal offer to our students, just because we don't want to have a student be offered something and then for financial reasons we not be able to follow through with it. So we want to make sure we really have our funding secured before we let the mentors know how many student slots they get. And step 4 is, I guess, kind of the fun part, is the collaboration part. That's when sponsors get to start working with their students, or with the students that they're supporting and the mentors they are supporting throughout the summer, at whatever level the sponsor is most comfortable with. And then they get to kind of get a report out by the students and the mentors of what work got done over the summer. And then we highlight them all at our Cross Symposium in October. And for this year, for any any sponsor who sponsors an OSRE student will also be recognized as a sponsor of Cross within the symposium as well. So it'll be a great chance to kind of tell everyone how all the great work that your sponsorship allowed to happen. Oh, so back to this. This is, so again, this is the timeline. If you want to look at it in in a more like straight line format, dates to keep in mind. The next one coming up again is pledges from sponsoring organizations. So basically that pledge form being done by April 9th. The student applications are due on April 30th. And again, from really over the next month and a half is when we'll be reaching more to students and getting these applications kind of started, having mentors and students starting to work together in that kind of the month prior to that application deadline. The May 13th date, of course, is important. That's when the funding deadlines, we see that the funding's coming in, and then that allows us to tell the mentors how many slots, how many students they're going to be able to work with over the summer. We will make official announcements of all of who got chosen and who's sponsoring who on May 19th, and then around June 14th, OSRE students begin their work. And we will wrap up about 3 months later on September 17th, although there's probably a little bit of flexibility there. And most importantly, early October, we'll have our cross symposium when we get to really hear about all the great work that the different students did over the summer. And with that, I'm going to open it, or I'm going to see if there's any questions or if Carlos had any other areas we wanted to focus on before moving it over to our mentors.
I think we're good. If there are any questions, now's a good time to maybe, but we are also going to have a question and answering period at the end, or even during the presentations of the mentors.
So I'm Jeff LeFevre, and I work on the Skyhook project. I'm an assistant adjunct professor here at UC Santa Cruz. And as Carlos mentioned, it's an incubator project. And a brief summary of Skyhook, if you're not familiar with it, is basically we utilize Apache Arrow and Ceph extensions that we develop such that we can apply query processing within storage, right? So like recently Skyhook has moved to a completely Arrow native interface. So on the front end from the user side, it's queryable through Arrow. And on the back end, we have embedded the Arrow libraries. So there's the dataset API is pretty rich. There's also an Arrow compute library. So all of these can be used to push down query processing, right, to the storage layer. And what that looks like in general is in our newer design, we ingest files as Parquet. Right? So in the dataset API, we can ingest data as Parquet files. And then we may partition this and chop it up and put this into different directory structures. And then at query time, right, we're able to take the user's input from the dataset API for the processing, say select or project, something like this, serialize that into a format that Arrow understands, that is shipped to all of the objects that compose the original data. And each object can utilize the embedded Arrow library that we built into Ceph CLS extension. So Ceph has extension mechanism called CLS. So you can actually write object classes to operate on the object data. And that's what we've done. So we're able to ingest data as well as push query processing down into storage for like a big data system. And this Arrow dataset API is fairly new. It's gaining quite a bit of traction. And Arrow is, of course, a really popular in-memory serialization format, also for data exchange. And now they have these compute libraries around it. There's an entire sort of ecosystem of functionality that we get by using Arrow and importing it. So that's kind of the status of the Skyhook project in general. And there's lots of different project ideas. If I go over to the project page.
I hope they're updated.
Is it updated? Okay. Yeah, thank you. Yeah. And so it's about 3/4 of the way down the project page is the SkyhookDM section. So I'll touch on just a couple of projects here real quick. And there's other projects we're always thinking of keeping in mind. So, please ask questions if you like, or, we're always open to that, of course. So the first project is the ability to create and save views. So the Arrow dataset API allows you to sort of ingest data, and we create these directory hierarchies, and that's the definition really of say your table, right? If you think of it in terms of tabular data. And over time, right, processing this data is compute intensive inside the storage layer, right? Well, maybe not entirely compute intensive. It's lightweight, but it's non-zero, right? So we'd like to be able to store previous computation, right, in the form of views. This is like a common technique in databases, so that we don't have to repeat computations. So the workload may observe queries or query patterns that are similar over time. And the idea with this project is, hey, let's save some of those results and keep them in the object right next to the original data, so that next time, we can utilize those if possible and save some, CPU, IO, and memory resources that we would otherwise have to use to recompute them. The second project regards the ability to push back computation to the client in the case of the storage system being overloaded. So as I mentioned, these Arrow compute libraries allow us to push down those functionalities and apply predicates in storage. But one feedback that we've gotten in presentations is the concern of overloading the storage, which is a real concern. So we have observed the Arrow functionality is actually pretty lightweight. It's not very expensive to apply the CPU to the computation. To the in-memory data, the CPU computation, the in-memory data. But nonetheless, at runtime, right, there may need to be a decision to say this, this storage server is too busy, it's overloaded, and maybe it needs to sort of reject that computation and just, ship back a message of some sort that says, here's what's left over, right? And that could also be done as described in this project, the sort of offline, right? So you could do a check every once in a while as well and kind of keep statistics on, if servers are busy or not. So you could do it sort of offline, or you could do it same methodology like at runtime dynamically if a particular server is just too busy. And the nice thing with the Arrow native system top to bottom, right, is that because we use the same compute libraries, whether in the client or the server, it's fairly straightforward to just, do the operation both, at the bottom storage layer or at the upper client layer, or either one. So that's kind of the idea with the pushback functionality. And if we go to the next one, I should mention, so for mentoring the projects, right, also myself and Evo, who's worked a lot on this project, and JG, who's been with us and done a tremendous job as well. For a while, originally, I think he came to us through Google Summer of Code. And he's been on board now for quite some time. So all these projects can be mentored by any of us, and we're happy to talk to people if you'd like. This one's a read the docs, right? So it's just more documentation. It's pretty standard, maybe for someone who just wants to do something lightweight project. The next one is integrating Delta Lake on top of Skyhook. So Delta Lake is a lakehouse querying engine for Spark. And it also provides ACID-based transactions. So it's the storage layer, and the idea here is we would like to put Skyhook underneath that. So it's farther below in the storage, as I mentioned, right inside Ceph at the object level. We were able to do these predicate applications. So we have a current project that's connecting Spark with Skyhook, and that's in progress. And so later toward the summer, we would like to put Delta Lake, say, on top of that, because Delta Lake provides Spark execution. And a nice benefit is also it lets users type in SQL, right? So you could have a SQL facing interface. And then just quickly, last project or two. One is Helm charts for deployment. And the other is continuous benchmarking and testing. So for deployment with one of our collaborators, the IRIS-HEP, so the Institute for Research and Innovation Software, for High Energy Physics, they have sort of a layered system here that involves, if we want to deploy all these things together, some analysis process or some task workers. This would be Ceph with Skyhook. So there's sort of several layers that we'd like to sort of simplify the deployments. And their engine ServiceX is a data delivery system that would ingest, that Skyhook would ingest data from ServiceX. So this sort of helps with, obviously deployment in existing user clusters. And then the last one is just about benchmarking and testing. So right now we don't have sort of a nightly build and test regression testing, and we'd like to add that. So in this project, we'd look at sort of the current best practices in the field and maybe things that Red Hat is using as well, and integrate that into Skyhook so we can see, performance changes or impacts of our code. Because there's a lot of moving parts in Skyhook. There's a lot of sort of trade-offs to be observed. So that's something that would be really helpful for us to see how our new changes are affected. And I think that's it. We have some other ideas about UDF functions and things like that we're developing for other projects that we can also talk about later. That's it. Thank you.
Great. All right. Checking for any questions from chat. So why don't we move on? Jose, are you ready?
Yes, let me share the screen. So thank you for giving me the opportunity. So let me quickly summarize, but if anyone has any question, feel free to stop me. So this is the LiveHD hardware project. So what is the quick summary idea is we are trying to do an open source hardware development flow. And if you are looking for a typical hardware, we read Verilog. We have a compiler infrastructure, it's like LLVM, like for people more familiar with compilers. And then we can generate Verilog, or we can synthesize, we can target FPGAs. We not only read Verilog, we can have other formats, like we output graphics for visualizing, or we can have a JSON format. More important, we have many languages. So we are really focusing our effort on having 3 language support, Verilog, which is the de facto standard for industry. Fertile or Chisel, which is a very popular, it's been used heavily for RISC-V community. And then we are trying to build our own language that we think has many advantages, that is Pyro. But the flow is multi-language. So it's an open source, multi-language flow. So the key novelties that we are trying to do, so that at least we see before we go over the projects, is it's open source. But then that's not a novelty by itself. There is a few open source blocks and pieces here and there. So the key novelties are that it's incremental. So it means that there are small code changes. We do incremental builds. That's something that most compiler infrastructures do, but the hardware community still don't enjoy this. The other one is that we want to have very fast feedback. And this is connected with incremental, but also that we are scalable, so that we can leverage multi-cores, we can go very fast response. And we support multiple languages, not only Verilog. That's the example I mentioned before, is like Verilog, Chisel, Pyro is the 3 languages that they are equal in the flow. So what are the projects that we have? And those are the different projects that they are open. And I think there are some smaller projects, but I think those are the most interesting. One project, 3-seater Pyro. Okay, so what is this project? What is 3-seater? 3-seater is a project done by GitHub, and it was for the Atom editor, but now it's used by several other editors. And the idea of the 3-seater is an incremental parser. So this fits very well with one of our goals, that is to be incremental. So as you type in the editor, they're able to parse, and they do very nice syntax coloring, and they provide good feedback. Now the same parser can be incorporated with our live hardware flow. So the idea of this project is we have a partially done 3-seater grammar for Pyro, is to finish it up, to integrate with the editors, and then to integrate with the LNAS code generation. If the student can make a lot of progress, it's possible even to try to see some of the incremental generations in our flow, but at least it will be to run without incremental. And that should be a totally reasonable project for the summer. So another project that we have, there is, as I mentioned, we are trying to be an open source tool flow for synthesis that usually we generate Verilog, but we can also synthesize for FPGA. So we don't build our own synthesis tools. So there are 2 main open source synthesis flows. There is ABC from Berkeley, and there is Turtle from EPFL. So the idea is to create a bridge with Turtle with EPFL. Now, it's not that we like more one than the other, is that this is one of the leading tools, and is to create an interface. So we started to do this a long time ago, and it was working, but we have been evolving the flow. Now there is some bugs. So one thing is to create a more stable flow in testing, regression, and fix the issues. Another thing that will be a little challenging on the project is that because we did this long time ago, the Turtle has evolved quite a bit. So it has to be reincorporated, and they have changed the APIs. So it's like to keep up with the latest things and to put it inside the CI regression system. No, this is a mistake. So the other project that we have here is the query shell. So as I mentioned before, what we're building a compiler infrastructure for hardware. This you can use just to compile, which is like, it will be like what GCC does. You have the input language, and then you output binary or whatever format. But you can also use it as an infrastructure to build tools around it. And this is an example of a tool that you can build. So you can read the hardware design, Now it's inside the databases in the compiler on the LiveHD. And you can have a tool or a console in this case, in which you can query things about the modules. Can you tell me what are the modules? How many cells does it use? Where are the drivers? Where is the critical path? Show me the path from here to there. You can query to learn about the design. So you can send queries. And the idea is to have a console in which you can interactively learn about the design. It will be possible even to interface with something like a JavaScript, which is a scripting language, so that you can build a bit more complicated query systems. Internally inside the LiveHD, there are two main data representations. There's quite a few APIs, but the two main representations is like LNAST, which is a language neutral AST, it's a tree-like structure. And there is LGraph, which is more like a graph representation. So the idea is you can represent any circuit with either of these two syntax, but there's some advantage to one or the others. But you can create many invalid representations. Like, for example, you can read a variable that was never written, or you can create an other block and there is no inputs. So you can do a lot of strange or mistakes representations. So the idea is to build a pass that is checks that there is a correct representation, and if there is a problem, it will flag an error, a warning to report. This is useful for anyone who builds any pass over those tools, so that it helps to pinpoint the error. It can be extended to be useful to provide hints to the programmer too. So there is the main goal is to help the designer of the tools, but it can be extended to help the programmer who is using those tools. So those are semantic checks. There was an undergrad working last year, working with LNAS. There are a lot of checks there. So the idea is to extend that, but create a new one with around LGraph. Then something that I think will be a separate project, but it's very useful for us and we don't have the capacity, and surprisingly, there is not a lot of infrastructure around, is to what we call like a terminal record replay. So in a way, when we have a lot of CI or continuous integration and testing in our flow, but at the end of the day, there is a user typing on a terminal. So the idea is to have an infrastructure in which you have a user, we record the user typing, and then we can reproduce this for testing. So this is a little bit similar to some tools that like the bash unit testing, but now it's been abandoned. I see no commits in the last 4 years. But in addition to what these tools do is also to use them for reporting performance. So we want to be fast. So we want to have continuous regression for performance in which user types the interaction with the tool. We see the expected result, but we also see the expected response time. And then we can keep plotting and seeing if there is a problem, we are getting worse performance than what we were expecting. So this is clearly a testing infrastructure that I think can be extended for other things, but it's something that it will really benefit our flow. Now, the last one, which is not on the list of projects, I have to add it because I was going over that recently with an undergrad student that maybe he wants to do it before, but I don't think so, is to integrate with Jupyter or Polynote. Polynote is the equivalent of Jupyter, but it was released recently by Netflix. And the idea of those tools is that you have a more interactive. So I will not do a cheap design with this, but they're extremely useful for teaching a language and for providing quick examples and to try little code snippets. So the idea is that you have a language. In most of those tools support always Python because they want to interface with AI. So you have a language, you type it more interactive on the browser. This talks to a server, the server executes and it provides the response back to the browser. The Jupyter is the one who started, but there are several things around. So the idea is to interface a Jupyter or Polynote with LiveHD, Pyro, Verilog. The Verilog bridge and pilot can be done with the LiveHD. So that will be like another project. And those are the things that I wanted to talk about and potential projects for undergrads. So if there is any question, otherwise we can move to the next speaker. Feel free to send me an email if later you have any question or an issue.
Thanks, Jose. Again, if you have questions about any specific, anything that our specific mentors are talking about, totally feel free to reach out to them directly. Note that all the contact information for our mentors is in the ideas page on their sections. They would list their email addresses or how to get in contact with them is on in the ideas section of the ideas page. All right. So with that, I will turn it over to Aaron Hunter.
Okay. Let me pull up the ideas page. So my name is Aaron Hunter, and the project that we're working on is, we call it the open source autonomous vehicle controller, but what it really means is that we're developing a piece of hardware that can be applied to any type of autonomous vehicle. It can be, you know, a car, it can be an airplane, it can be a submarine if you want. The point of the project, though, is that existing commercial autopilots or vehicle controllers are very difficult to modify in terms for research purposes. In other words, if you wanted to implement your own new vehicle type, you have to become, well, it's a very difficult process to modify the existing commercial ones. Even though there are even some that are open source, they're really designed around a specific accepted vehicle dynamic, and it's hard to modify that. And additionally, it's difficult to apply other types of areas of research that are used in autonomous vehicles as well, such as developing new and novel state estimation algorithms, designing sensor calibration algorithms for new sensors, or incorporating multiple sensors into a single measurement. So the idea of this project is to be able to provide a piece of hardware where making those changes is actually quite simple. All you have to do is change a single C function for one of those classes of changes, whether it's the model vehicle type, or let's say the dynamic vehicle model, the state estimation algorithm, or even some of the sensors themselves. So to support this, we came up with a list of projects that could be done by an undergraduate, from relatively easy projects. Like the first one I want to talk about is basically, in order to make the hardware more useful, you need to be able to integrate multiple different types of sensors. Now we've developed sort of a minimal set of sensors that would be useful for, say, an autonomous car, but there are specific sensors that might need to be used for a project where we don't want to just develop a library for every type of sensor out there. However, if there is a larger set of sensors to choose from, then it makes the hardware more adaptable for different research purposes. So from that standpoint, then one easy project, relatively easy project, is to choose a sensor and write the sensor driver under guidance from us on sort of the best practices to implement real-time modular and non-blocking algorithms that can then be integrated directly into the hardware that we're developing as a new sensor. So we basically develop a sensor library that would be used for a specific type of measurement. Inside that project, actually, there's one that I've been thinking of that's a little bit more involved, which is to actually develop a sensor module where, for example, I was thinking it would be useful to have a rangefinder, which is to say a laser measurement, but on an XY gimbal, so that you could direct it and determine how far you are away from any given object, or alternatively to measure how quickly an object is moving towards you and in which direction. So there's kind of like a couple different potential projects that are in that category. Then as we move up to sort of more challenging projects, these are ones that are more amenable to just pure programming. So the first in the list is essentially an IMU, which is to say the IMU is an inertial measurement sensor. It consists of 3 types of sensors usually. And the idea is this is a fundamental sensor involved in any type of autonomous vehicle. And there's a lot of research going on in terms of what is either a computationally inexpensive or a higher accuracy way of doing this. And so one project would be to using simulation software such as MATLAB and Simulink to develop a numerical routine for providing a calibration for the sensor, and then being able to use that then to correct the raw measurements coming in from the IMU sensor itself. And as we go to sort of next level difficulty, there are, again, for reasons of either computational complexity or for better senses of accuracy, there are simulation projects where you want to perform what's known as the state estimation, which is basically to say, given a set of sensor data, what is the optimal state estimation from that sensor data? An example of this is given an input from your GPS measuring position and from your accelerometers measuring the direction of how fast you're accelerating, as well as the direction of gravity, a magnetometer, which might measure your heading, and gyroscopes measuring how quickly you're turning, any number of these types of sensor measurements. What is an optimal method to fuse all that data into a single state estimation, which is to say where you are in the world, what direction you're heading, and how fast you're going. So this is a little bit more complex. It would involve either using commercial software such as MATLAB and Simulink to develop the algorithms and then port it into C code that we could then incorporate into our library of algorithms that are easily swapped with the hardware. And again, we would provide guidance on the particular types of estimation algorithms or filters that are used in this, so that a student wouldn't be given an open project, really. And then sort of the last most complicated task that we could imagine is actually coming up with the dynamic model of a new vehicle type. This project that we're working on will implement sort of the conventional model of an automobile. But if you wanted to have a model used for a boat, that's a very different dynamic model. And so similarly, if you have an unmanned aerial vehicle, like a fixed wing drone or a quadcopter, uses an entirely different dynamic model. And it'd be nice to have a library of sort of the conventional models for some of these vehicles, such that anyone, researcher, could use those models to build or to build off for their own specific use. So it'd be nice to have a library of different vehicle dynamics. And so that's kind of the suite of projects that we could envision offering to undergraduates or even maybe at some level some graduate students. So that's kind of the gamut of the projects that we're thinking of. I'd be happy to answer any questions with regard to all of these. Okay, you feel free to contact me for my contact info, and I can give you more information if you need. Thanks.
Thanks, Aaron. And the last mentor we have in project we're going to hear about is Jianshen Liu, who talks about the Eusocial project.
So I'm Jianshen Liu. I'm the research fellow for the Eusocial storage devices project. And so just some of the background of this project. The idea of this project is that we want to create collective acting embedded storage devices, and so that these devices would be able to take over some of their functions that require communication between nodes onto these devices. For example, functions could be the load balancing function and the failure detection, failure discovery function, recovery function, things like that will be able to flow to the collective acting storage devices. And so the benefit is that because this embedded storage device is now being able to operate by themselves autonomously without the help of a host to conduct these kind of functions, and so they can remove the host text working on some of the I/O actions, I/O operations. And second benefit is that it can reduce the data movement, and so that it can do some operations within the device without sending all the data back to the host and to the memory. Then it started to do the execution. And finally, because these devices can independent of the host, and so essentially create more failure domains for the system. And our previous paper showed that when we have more independent failure domains in our storage system, essentially they will improve dramatically the data availability of the system. And so also another important thing is that we, because the resource availability of these devices are limited, and these devices would also need some pushback capability when the resources inside the device is not be able to give good performance if it continues to exceed this some of the function. In that case, it would be better to push back some of the function execution to the caller, to the clients, or the executor. And so in this project, we also considered, as you can see, some of the project idea also related to the SmartNIC. And the reason is that the SmartNIC also contains some computing resources within it. And so even though it doesn't have their storage, this device is not mainly focused on this persistent data, but because they have the computing resources, we can leverage those resources to take over some of the data transformation and or the asynchronous operations are original running on the host. And so the first project idea is that we have some previous experiment running in our representative SmartNIC and show that the kernel network stack on the SmartNIC is not efficient enough to saturate the hardware bandwidth of the SmartNIC. And because modern SmartNIC typically support 100 gigabit per second throughput, and so which means the computing resources within SmartNIC is not enough. But on the other hand, when we tested the user space network stack such as DBDK, in that case, the SmartNIC can saturate the bandwidth itself, and so we just want to know by doing this project, we want to know how efficient of the user space solutions, including DBDK, and also there is another user space network solution provided by Mellanox and called VMA, and we want to compare the performance differences between them and know more about the capability boundary of the SmartNICs. And the second idea related to the RocksDB. As a previous, we read a paper about inside the RocksDB, when we do the data compaction into the next levels in the LSN tree, we probably can piggyback some of the data transformation inside the compaction process. An example would be that as the data get compacted into next level, we can change the data layout into, for example, the column-based format from the row-based format, and such that when the data access is more favored to some specific data format, it would be best if we get the benefit from the transform the data layout. And so we think that because the workflow is different, maybe some of the rows or columns would like to always stay together to further accelerate the access. And so it would be better to create some a layer such that the user can inject some the data grouping strategy into the RocksDB during the compaction procedure. And so remember that the RocksDB would also be able to maybe able to run inside the embedded storage devices. And so there could be further help to increase the capability of some of the users of storage devices. And so the last project related to the idea of leveraging some of the memory semantic technologies such as C6 and CXL, and as well as Gen Z. And these memory technologies would is kind of a cool idea to apply on the user storage devices, because for application, it may, when it runs inside one of the user storage devices, it may be able to access the memory on another devices, but without the node, without any, but the application running on the devices would not know any about the details, because the underneath memory transformation memory virtual memory layer would handle all the pointers, manipulation, things like that. And some of the like the C6 and CXL would create a coherent memory layer for nodes, for distributed nodes, while the Gen Z doesn't create a coherent memory layer, but it create layers such that applications, when application access some of the memory address, the layer will translate that pointer to the place reside on another node. And so we think it will be a good feature to learn from this new technology and how does it fit into our project. I think this all about this project. And if you have any questions, please let me know.
Thank you.
Okay, thanks. Bye.
Bye-bye.